In our previous video, we learned the derivatives of basic trigonometric functions, and we also learned how to prove them using first principles. I recommend you to watch that video before watching this, since it will be much easier for you to understand the tricks that I will be using here. Today, I will be proving the derivative of fx equals sine ax, where a is a constant, using the first principles. Here we have f of x is equal to sine ax as our first equation, and like before, we can write our second equation as f of x plus delta x is equal to sine a into x plus delta x. We have to mention here that delta x is an increment of x. So when we subtract equation 1 from equation 2, we get f of x plus delta x minus f of x is equal to sine ax plus delta x minus sine ax. So if you remember in your trigonometry, sine c minus sine d can be written as 2 into cos c plus d over 2 into sine c minus d over 2. So we apply this formula here. So this will give us f of x plus delta x minus f of x is equal to 2 into cos c plus d over 2, that is a into x plus delta x plus ax whole thing divided by 2, multiplied by sine into c minus d over 2. So that will be a into x plus delta x minus ax whole thing divided by 2. So now we can open these brackets and simplify this. So that will give us ax plus a delta x plus ax, that is 2ax plus a delta x divided by 2. Here ax and ax will cancel off, giving us a delta x over 2. Now we divide both sides by delta x. So this will be f of x plus delta x minus f of x divided by delta x is equal to 2 into cos 2ax plus a delta x over 2 into sine a delta x over 2 whole thing divided by delta x. So when we simplify, here we bring the delta x under sine a delta x over 2. You know the reason why I did this. I explained this in our previous video. I'll explain it again here. So when we apply the limits to both sides, we get limit of f of x plus delta x minus f of x divided by delta x as delta x tends to 0 will be equal to, here on the right hand side we apply the limits separately, just like we learned in our previous chapter. So that will be 2 into limit of cos 2ax plus a delta x over 2 as delta x tends to 0 multiplied by limit of sine a delta x over 2 divided by delta x as delta x tends to 0. So here we can simply use direct substitution. So that gives us 2 into cos 2ax over 2. Here the left hand side is our f prime x or dy by dx. So for this part, what we do is we try to make it look like our formula here, that is limit of sine x over x as x tends to 0 is equal to 1. So we try to make this part of our equation look like this. So for that, here this part and this part, the denominator should be the same. So here we have a delta x over 2. So the denominator also should be a delta x over 2 according to our formula. So what we do is we multiply the denominator by a over 2, and we cannot just do that. So to balance it out, we have to multiply the numerator also by a by 2. So that's what we have done here. We have multiplied the numerator and the denominator by a by 2. Now we have it like a formula here, that is sine x over x, but the limit has to be changed. So for that, what we can see here is that when delta x tends to 0, a delta x over 2 also will tend to 0. So we can simply substitute delta x tends to 0 by a delta x over 2 tends to 0. So now we have this part like our formula. So that will be 2 into cos ax. Why? This 2 and this 2 cancels off, giving us cos ax multiplied by limit of sine a delta x over 2 divided by a delta x over 2, as a delta x over 2 tends to 0, multiplied by a over 2. So this part will be equal to 1, giving us our answer 2 into cos ax into 1 into a over 2. So here 2 and 2 cancel off, giving us a cos ax as our final answer. So this is the derivative of sine ax. If you remember from our previous video, the derivative of sine x is cos x. When we compare these two, we can see that the derivative of the trigonometric function with the constant is equal to the constant multiplied by the derivative of the trigonometric function. For example, the derivative of sine 2x will be first the function, that is 2 into the derivative of the trigonometric function, that will be cos 2x. Remember that the angle 2x will remain here. Similarly, we can find the derivative of the other trigonometric functions with constants. The derivative of cos ax will be minus a sine ax. So the derivative of tan ax will be a sec squared x. The derivative of cosec ax will be minus a cot ax cosec ax. The derivative of sec ax will be a sec ax tan ax. And the derivative of cot ax will be minus a cosec squared ax. When you look into all of these derivatives, you can see that they follow the same order. The constant multiplied by the derivative of the trigonometric function. So this can be clearly seen using these two tables. So we have plenty of exercises for you to familiarize yourself with these formulas. You can also try deriving the other functions using first principles. If you have any problem, please feel free to ask us in the comment section below. We are always ready to help you. Until we meet again, take care.